This is the Marron Carrel Model 1400 Rostrum camera. The Rostrum camera is so named due to the large platform on which the artwork is placed and the camera is mounted to. Such a camera can be used as a copy stand to simply photograph artwork, to duplicate slides, or to create complex graphic effects slides with precision. Another name often used was the optical printer. The Rostrum camera was especially adept in creating precision special effects slides and graphics. With its ability to make multiple exposures on the same frame of film without advancing, and the programmable motions of the artwork made possible the slide graphics you see here and others. First introduced in 1980, the Marron Carrel quickly grew to be a favorite among many multi-image producers. The Marron Carrel 1400 included many advanced features such as a fully motorized compound for X, Y, and Z axis movements, as well as a 360-degree rotation, all computer controlled and programmable. The remote and programmed control of copy lighting with up to 7 light modes. A projected reticle alignment grid, or an eyepiece viewer that views through the reticle and lens assembly. A 400-foot film capacity for 16, 35, or 46 millimeter film. The ability to autofocus as the camera moves up or down. Here we see a mechanical cam that moves with the camera as it travels up and down the column. The future MC1600 will have a programmable motor in place of this cam. The ability to program functions and movements for faster or repetitious procedures. The future MC1600 will have an Apple II computer added for more programmable features. This red LED display shows the positions of the 3 stepper motors in the compound, as well as other information such as what exposure the camera is on and if the camera is out of film. The ability to change to a variety of lenses and lens extension tubes to go from wide angles to macro photography work. The ability to change the camera quickly and easily to a 70mm or other camera. The ability to change the camera from 35mm film to 46mm film by changing the aperture plates. This was an optional feature from the manufacturer. You can see that the film rollers are built with both 35 and 46mm sprockets. Spacers in the film magazine are also changed for the larger film. The camera zoom is controlled from a separate box with 2 buttons and a knob, a button for up, a button for down, and a knob for variable speed control. You could see an LED display to the right on the table. This tells the position of the camera as it travels up and down on the column. These positions are used for programming in the computer. The compound, also called the stage, gets its name from the multiple precision movements it can make, all of which are programmable in the computer. It is this precise movement that enables the creation of special effects slides and graphics. Here is the stepper motor for what was referred to as the east-west motions of the compound. The stepper motor can be actuated one step at a time or through a range of steps to be programmed into the memory. Here is the stepper motor for what was referred to as the north-south motions of the compound. Here is the stepper motor for the compound rotation. The center key sends all motors back to the previous 0 position. The compound can be easily released from the motor drives to manually position the stage. A variety of film carrier plates can be interchanged quickly. Here is a large format film carrier plate with Acme registration pins. These plates are held in place by mounting pins. Here you see a carrier plate for holding standard slide mounts. Here is a carrier plate to hold 35mm film in place via these registration pins. Here we remove the film carrier plate altogether and replace it with a piece of frosted plexiglass for use with backlighting 10-field mechanical art. Originally, this would have been a double-flashed piece of opal glass. The compound is equipped with adjustable Acme registration pins to hold the artwork in a precision location. The camera is fitted with a 12-field reticle alignment grid. The term reticle refers to the small lines that represent precision marks as it relates to the frame of film, similar to the crosshairs of a rifle scope or the pointer marks of a telescope or microscope. The reticle is located on the viewport of the camera. The grid includes lines for 16mm film, 35mm film, TV safe, 35mm number 2 mount, 46mm number 2 mount, and 46mm number 1 mount. Here we see through the viewport, through the lens, onto the artwork on the compound. We use the reticle lines to precision the artwork as desired, as we want it to be on the frame of film. We can also use the viewport eyepiece to magnify the view if so desired. The camera is also able to project the reticle grid onto the artwork using the reticle projection lamp. Here you can see the reticle grid projected through the lens and onto the artwork. The grid is used to align the artwork to the film about to be exposed. The following is the procedure to load new unexposed 35mm film into the supply magazine. First, we remove the supply magazine from the camera head. Bring the magazine to a table and open the magazine. Remove the bulk 35mm film of choice from the can and place the roll of film into the magazine with the tail of the roll to the right. The magazine will accommodate up to 400 feet of film. Thread the film through the bottom slot and leave at least 12 inches of tail. Replace the cover onto the magazine and you are now ready to load the film onto the camera. This procedure must be performed in a dark room or else you will ruin your new film. Perhaps I should have mentioned that in the beginning. Sorry. Now we will thread the film into the camera. First, remove the take-up magazine and open the camera chamber. Press the load film key to raise the pressure plate. Here is a guide of the different sprockets and rollers inside the camera. Please notice the slot in the pressure plate that the film must pass through, not under. This way the pressure plate can lift the film off the registration pegs when the film advances. Place the supply magazine loaded with unexposed 35mm film of choice. Thread the film tail into the camera and pull at least 24 inches of film into the camera chamber as a leader. Reattach the magazine drive band onto the supply magazine. Place the film under the first roller, under the next roller, downward over the left side of the center metering sprocket, making sure the sprocket holes of the film engages with the metering sprocket. Then pass under the next roller and go left to the outermost roller. See how this roller is spring-loaded to provide tension on the film and to actuate the out-of-film indicator on the control keyboard. Leave this tension arm loose for now as the film proceeds through the slot of the center pressure plate and onto the registration sprocket. At this time, we pull on the film leader to tension the arm, and then the film is placed into the pins of the registration sprocket. While holding the film onto the registration sprocket, continue threading the film upward along the left side of the metering sprocket and towards the outer right rollers. We can now let go of the film at the registration sprocket. Press the load film key again to lower the film pressure plate. Gather the take-up magazine with the cover removed. With one hand, hold the magazine and insert the film into the magazine with the other hand. Lower the magazine onto the camera and lock into place. Place the drive band between the motor drive and the take-up magazine. Attach the film onto the left side of the film core and spin the reel to take up any remaining film leader. Place the take-up magazine cover onto the magazine. Press the frame advance key several times to check and test the transport of the film. If satisfied, close the camera door and advance the frames at least 12 more times. The camera is now loaded and ready for use. The camera is also equipped with a film notcher for use if your processing lab does not accept long rolls of film. The standard practice was after 36 exposure, you would advance the film 9 exposures, notch the film, then reverse 5 exposures, and continue with your work. The notcher would be activated by a key just to the left of the 0 key on the keyboard. Later in the darkroom, you would then cut the film at these notches to make the smaller rolls. Before we describe the in-camera mask feature, or ICM, let's first describe what a mask is. We will only briefly discuss this process as masking can be quite elaborate and complex and is the subject of another video. A very popular technique among multi-image creators is superimposing images, or placing an image within another image. As an example, let's project a landscape over the entire screen. Then we add other smaller images of trees, rivers, and animals on top of the landscape image. To add these other smaller images, dark areas must be created in the large landscape image where we want the smaller images to go, so the smaller images won't blend in with the background. These dark areas are the masks as they mask off an area of the image. These dark spots must be precisely placed and be of a precise size to match the image being superimposed. The Rostrum camera was made with this precision. This technique of masking can be done in a large format on the compound, or it can be done by using the in-camera mask feature, or the ICM. To make an ICM, we must first prepare some film. In a dark room or in a room with only a dim red light, we take a large format sheet of Kodak Kodalith or similar film and cut it into 2" by 2" pieces. Kodalith film is a high contrast black and white film where there is only black or white with no shades in between. Whatever art is light in color will turn out black, and whatever is dark in color will turn out clear on the film after processing. We then punch registration holes in the film using the ICM punch. Notice that there are 2 sets of holes. This will be explained shortly. You can see here how the ICM film fits onto the 35mm aperture that is inside the camera. However, if you're using the 46mm film and aperture, you can see here how the holes are inside the image area. So when using the 46mm film and aperture, the extra pins of the ICM punch can be removed easily as needed. When finished, we place the film in a light-proof box. Again, with the lights out or only a dim red light, we load a piece of litho film into the ICM slot of the camera. With the pressure plate lifted, we place the litho film under the pressure plate and on top of the aperture plate and into the ICM registration pins on the aperture plate. We use the outside-most set of holes in the film. If there is film already loaded in the camera, then all lights must be turned out or the 2 feet of film inside will be ruined. We then set the artwork that will form our mask. In this example, we place a piece of blackboard under the camera. We then take a small piece of whiteboard cut to a specific size and place it on top of the blackboard in a specific position by using the reticle grid for reference. We then expose the film to this artwork. We'll load a second piece of film and make another exposure of the mask as a duplicate and process the film. After processing, you get a film chip similar to this, where there is a dark rectangle within a clear area. This is our ICM. We then place the ICM into the ICM slot of the camera loaded with color slide film. The following pictures we'll take will have this dark mask area on the images. We can also use the duplicate ICM to place on top of the viewport using the reticle matte pin bar to hold the ICM in place using the second set of holes in the film. The first set of holes must be cut off first. This allows us to see where the mask will be in the upcoming exposures. To make the images that go inside the mask, we need to make a negative ICM by making a contact print of the positive ICM. To make the contact print, we'll use our ICM jig. In a dark room with a dim red light on, we'll place a piece of prepared Kodalith film in the registration pins on the jig. We'll then take our positive ICM and place it on the jig on top of the Kodalith film using the same registration pins. We then use a light source to expose the positive ICM onto the film. It is best to use an enlarger for a better controlled light source. Then take your film for processing, and you will get your negative ICM. We then remove the positive ICM from the camera and load our negative ICM. We also load a duplicate negative ICM onto the eyepiece. And now we have reference on where to place the artwork to photograph for inside the masks. There's also the option of loading the camera with a spool of 35mm Kodalith film instead of cutting up small pieces of large format Kodalith film. This will require some extra cutting and taping and hole punching, as you can see from this diagram here. Okay. After processing, we cut the film into individual chips and place a chip onto the ICM jig using the 35mm registration pins. One side of the jig has pins for 35mm sprocket holes. The other side of the jig has pins that fit holes made by the ICM punch. After fitting the 35mm film chip onto the film jig, we cut up a piece of scrap film material and punch holes using the ICM punch. We then place the scrap film material onto the jig and cut it to size to mate up with the 35mm chip. We then tape the two pieces of film together to make the ICM. This option could be very tricky, as a slight mistake while taping the pieces together will result in the mask being out of registration and all the following images will not align properly. When using 35mm ICMs, there's a different reticle matte pin bar that will mount a 35mm chip without having to add the extra piece of film material. The Marron Carrel 1400 has many options of light sources for the work being photographed. With the use of the light mode key on the keyboard, 8 selections of the onboard lighting can be used and programmed for repetitive functions. Such light modes include the overhead lighting to be on, or at half intensity, or only on during exposure. Other light modes include the activation of the reticle projection lamp. There are also options for light sources from under the table. One option is a tungsten light source that can be color adjusted with color filter media. A preferred option is the Omega dichroic light source. The Omega D5500 dichroic light source is a subtractive color mixing device consisting of a light head cabinet, a control panel, and a cable connecting the panel to the cabinet. The engineers at Marron Carrel modified the front panel of the D5500 for better operation and functionality. The Omega D5500 was originally designed to be used overhead in photographic enlargers. When used on the Marron Carrel, it is mounted upside down to the bottom side of the table using a mounting plate fastened to the light cabinet. Usually the mounting plate is a piece of black aluminum, but today we're just using a cheap piece of plywood. The light head assembly is then installed to the underside of the Marron Carrel table by using the mounting toggles already in place. The control panel can then be placed at a location convenient to the operator. The Omega D5500 is equipped with a 50-watt MR16 lamp lighting the mixing chamber through 3 secondary colored dichroic filters of cyan, magenta, and yellow. Each of 3 color filters are moved into the light path via an electric motor. The more the filter blocks the light path, the more saturated the light is of that filter's color. There is a separate dichroic filter for each secondary color. Combinations of the 3 filters can be made to result in a desired color output. The Omega D5500 can be easily opened and the mixing box removed. As you can see here, the mixing box is a simple piece of white styrofoam at an angle. The mixing box then serves to mix and diffuse the colored light coming from the dichroic filters. Frost or diffusion media can be placed here for other light effects. Here you can see the light sensor array. The computerized control panel can automatically adjust the filters to a specific color mix by reading the light output. This provides a higher degree of color mix accuracy that can be recalled at any time. The light output can be adjusted to provide desired color temperatures or to provide colors for use in photographic effects. In later years, the Omega color head would be replaced by the ZBE dichroic color head. The ZBE was brighter and could be programmed directly from the camera's computer. There were several models of Marron Carrel Rostrum cameras, all based on the multi-image producer's needs. Here we see the catalog page for our Model 1400. Here we see the catalog page for the smaller Model 900. Here we see the catalog page for the even smaller Model 600. Here we see the catalog pages for some of the options that the camera could be modified to provide. Such options include rotoscoping and film bypacking. Not shown here are the models 500, the Model 1100, and the future Model 1600. The Marron Carrel 1400 had a total height of 9 foot 10 inches, a total width of 10 feet, and a total depth of 4 feet, and weighed up to 800 pounds. It consumed 15 amps of 120 volts AC. Thank you for watching our video. I hope it was as much fun to watch as it was to make it. And we apologize for the errors in photography.